Okay, everyone, sorry that I had to cut this lesson into two videos. I had a bit of a problem with the recording. Anyway, we're going to continue on here with example number 13, page 185. I just kind of want to give you some more examples for you're still comfortable with how to do all of these. I started out here with my basic example. Mechanical energy is energy kinetic plus EP. This is nice to actually tell us that our mechanical energy value is 0.481 joules. We don't know our EK, but I believe that we know enough probably to figure that out. And you're going to notice that we're going to leave right now our variable, or sorry, our value of EP is what we're going to try to find. Now, this question, there is a little bit here, so you know EK is 0.5. What you have to find, of course, is your mass. Now, this is one of the times they're going to try to trick you because they've given you grams, and of course, we need to use kilograms. So what you need to do is take that 20 and divide it by 1,000, and that's going to give you 0.02 kilograms. And of course, your velocity is 4.10 meters per second squared, or sorry, 4.10 meters per second, and we have to square that, plus EP. The next step would be to calculate your kinetic energy. So that's simply going to be 4.1 squared times 0.02 times 0.5. That gives us a value of 0.1681 plus EP. What we're going to do now is we're going to subtract the 0.1681 from both sides. That's going to give us EP. I should scribble that out. 0.481 subtract 0.1681. That gives you 0.3129 joules. I believe we need to have this into 3 significant digits, so that should be 0.313 joules. Now, again, please make sure that you understand how to work out that question. Make sure you understand the algebra, the setup, the units, the significant digits. But you see, I mentioned earlier how sometimes, you know, not every question uses the same formula. So I want you to make sure you know how to do number 13. And then we're going to move on to number 14. Now, number 14 has to do with a pendulum. And in my next slide, what I'm actually going to do is I'm going to show you some basic characteristics of the pendulum. But I wanted to see if we could try the calculation here first. Because when you first read these questions, you're thinking, wow, look at all the things that are going on here, and this gets a little bit overwhelming. But it's not too bad. What I want to do, though, first is I want to write down our formula. So remember, EK is 0.5 mv squared. Remember that EP is mgh, and remember that mechanical energy is EK plus EP. Now, so we're looking at number 14. So what you have here is you have a pendulum, and it has a 500 gram ball suspended. So basically, here's the ceiling. It's hanging down, okay, and you have the weight. It's 500 grams. Now, the string is 50 centimeters. The ball is pulled horizontally and up a total distance of 10 centimeters. It is then released. So what's going to happen is what they've done is they basically it's hanging down 50 centimeters. They pull it this way, so it's kind of over here. And the biggest key here is that it's only gone up 10 centimeters. Okay, now you see, that's what you have to understand. We're going to get into that in the next slide here. But I want to talk about the calculation here. So please don't get caught up with the ins and outs of the pendulum for right now. What I want to show you is the formula. So now, it says here, we know how long the string is. It says it is then released. At the bottom of the arc, the mechanical energy of the ball was 0.491 joules. What was the speed of the ball at the bottom of the arc? And, I was thinking about this question, and I thought, when should I show you this one? How should I do it? My point with this question is I want to show you how sometimes you have to be creative with the formula itself. Now, what we know here, everyone, is we have mechanical energy. They have told us that value. They also want to know what was the speed of the ball at the bottom of the arc. Well, if you think of it, the pendulum might be pulled up here, and it might come down over here, and then it might go back up and then swing back down. But think of it. At this point right here, what kind of energy do you have? Well, you see, when you pull it up and you have it over here, it has some potential to fall. This part right here should be the fastest point. Can the string and the ball fall down anymore? No, it cannot. At the very bottom, all you have is EK. Now it tells you, very tricky here, at the bottom of the arc, the mechanical energy of the ball was 0.491. Well, what kind of energy do we have at the bottom of the arc? You see, our mechanical energy is equal to our kinetic energy. So what you have to do here is your mechanical energy is 0.491 joules. And remember, at the bottom of the arc, that is kinetic energy. So when they tell us it's 0.491 joules, that's our kinetic. Now do your formula. And put in now what you can do. Your mass was 0.5 kilograms. You have to change that. And here's your velocity squared. My point is, we can go through the calculation, 0.491 joules. I'll multiply that side. So that's going to give us now, oh, my calculator turned off, 0.5, should be 0.25. We'll multiply both sides by 0.25. V squared is equal to, so we'll go 0.491 divided by 0.25. It's 1.964. Square root. The velocity is, second function square root, second function answer. I got 1.40 meters per second. Anyway, again, my whole purpose here is not so much the pendulum, it's not so much, the physics of that. What I'm trying to show you is that you have to be creative with these formulas. In this case, you can't just take what you've been given and rely on that. Sometimes you have to be putting things together. It told us here about mechanical energy at the bottom of the arc. Then you had to think, well, at the bottom of the arc, all I have is kinetic. So my mechanical energy equals my kinetic energy, and that led to the calculation. I hope that makes sense to you. Finally, now I thought I'd take a moment and just get into the actual the pendulum itself. We don't need to do this very long, but essentially with a pendulum, what you do have is you have a string or something attached to the ceiling. Now, at the very bottom, of course, the pendulum might be pulled up into, let's say, this position up here, and it'll be released, and it'll go somewhere over here. I just want to talk about the types of energy that you have. At the very bottom, at the very top, we'll go top right-hand side here. It hasn't been released yet, so all you have is potential energy. If we were to put the pendulum at this point, halfway down, remember, that would be a mix. It would have movement, so it would have EK, but does it have more to fall down? Yes, and that's your potential energy. At the very bottom, that's where you'll have your fastest point. It has EK, it has its energy of motion. Can the pendulum fall any further down towards the earth at this point? No, it cannot. And then, of course, we'd go back up the other side. And of course, conservation of energy. I mean, if we had 100 joules here, we'd have 100 joules here. We've done this now 2 or 3 times. The whole point, everybody, is I simply want you to understand that energy is conserved, and it's changing between EP and EK all the time. And, you have to be creative with your formulas. And I will give you some practice here with using these formulas to solve some problems. Please check your answers. And, this would be a good point in the course of this section to really, make sure. Can you calculate all of these things? How's your algebra? How's your sig digs? This would not be a part of the course where you'd want to move on before you really have figured things out.